Hello everyone, this is Sharanjit Singh from California State University. Today we're going to talk about is gallium nitride the next semiconductor for power electronics. So today we'll be covering gallium nitride physical properties, why gallium nitride, technical advances, and the startup of gallium nitride in power electronics, future and applications. So we'll be heading up with the physical properties. So talking about gallium nitride has a wide bandgap semiconductor with bandgap of 3.4 electron volt with high heat capacity. It can be doped for N-type with silicon or oxygen, and for P-type we can be using magnesium. The compound has a wurtzite crystal as shown in the slide on the right and bottom side. It's a wurtzite crystal which makes it a hard material. The structure itself makes it a hard material. Such high bandgap materials are used in optoelectronics for high power and high frequency devices. And another thing is that it can make violet laser diode possibly without use of non-linear optical frequency doubling. And another feature for this is that it's a non-flammable compound. Before we discuss the details of this compound, let's see why are today's leading designing engineers turning to gallium nitride. First is the performance or efficiency. Gallium nitride is faster and more efficient than the silicon with, with switching speed of currently 10 times better than the silicon, and gallium nitride enables higher frequency, smaller size and lower overall system cost. It is also giving as new application which expands the entire semiconductor market. Gallium nitride is cost effective. They have been proved as simplest and low cost devices to be manufactured. In addition, the elimination plastic packaging further reduces the cost of manufacturing. So overall, it reduces the cost with the many of its applications. So now let's see this figure which reveals the difference in the gallium nitride and the silicon. You see the blue line, it's the gallium nitride, and the line inside the blue line is a violet line that says silicon. So you can see that the high operating temperature for gallium nitride is 400, while it's for silicon is nearly between 100 to 200. Similarly, you can see the high breakdown strength for gallium nitride is much more higher than the strength of silicon. Silicon is under 100 and the gallium nitride is above 300. Similarly, go down, it says high maximum current where again silicon lacks, and for the superior noise factor again the compound gallium nitride is more superior than this silicon. Now the technical advantages. It reduces the heatsink requirements, and it even reduces the volume and the weight by 80%. As you can see in the figure down, it says the motor and the factory automation reduces weight and size by replacing copper and aluminum by gallium nitride. So the weight is reduced by 80%, and the output of the power is increased, and the reduced electrical noise from smaller system packages. It even reduces the noise. So now coming to this slide, it's a start of gallium nitride in power electronics. Gallium nitride as a compound was used before 2004 also, but in power electronics it was used first in 2004. It was used by HEMT, which is also known as high electron mobility transistor. In gallium nitride transistor, this appeared in 2004 with depletion mode RF transistor made by Udana Corporation in Japan. Using gallium nitride on silicon carbide substrate, Udana designed such transistor for the RF market. Secondly, it came in June 2009. Efficient Power Conversion Corporation, which is also known as EPC. It introduced its first enhancement mode gallium nitride on silicon design specially as power MOSFET replacement. These products were designed to be produced in high volume at low cost using standard silicon manufacturing technologies and facilities. Talking about the future of gallium nitride, many of the big institutions are putting their efforts to make gallium nitride as a new semiconductor. The Department of Energy dedicated half of the 148 million research institute towards the research of gallium nitride so that it reduce the energy of consumption potentially, And the MIT spin-out Cambridge, they announced that gallium nitride is gonna reduce the worldwide customers' energy uses by 10 to 20%. Now the question arises, does it enable significant new applications? As it has many good properties, but it has to be having new applications and helping us out there, as marketing is application, not the properties. So we'll be seeing where we can fit its properties and getting new applications, better market. So now coming up to the application, let's see the transforming space. Gallium nitride can withstand 10 times the radiation of aging tolerance power MOSFET and 40 times better electrically. Now coming up to the electricity part, it can give a new application, that is a high power wireless transmitters. High power wireless transmission has high frequency of 6.78 MHz, which has been adopted as a standard frequency because it allows thin coil and shielding, while silicon does not perform at this frequency. So it is gallium nitride which can give us such an application which can be widely used. The another application future which could be coming up is integrating thin transmission coil in the floor tiles and the walls of the building, which can eliminate the socket in the home. This is a newer technology which can be coming up with the gallium nitride. It is somewhere used like with the people with electric vehicles. They have coil floors so that they park their vehicle and the car start charging up. So it's gonna come in home also, so that we won't have any other socket. Now coming with the communication sector, it can be used in communication sector also in RFDC, which is also known as envelope tracking. It is a power supply technique which doubles the energy efficiency. Techniques of RF power amplifier used to transmit all of our voice data via satellite, base station and cell phone. It is accompanied by tracking power demands precisely and providing power exactly to fit the amplifier signal modulation needs. So it is another very important aspect of gallium nitride which can be used in the communication, which can directly link our phones to the satellites, and it can be used for further enhancement of the voice signal. Another important application for gallium nitride is high energy pulse laser, that is LiDAR. Light detection and ranging. This application uses pulse laser to rapidly create a three-dimensional image or a map of surrounding area. LiDAR technology allows for high accuracy, larger coverage area, and increased speed and efficiency of data collection. This technology has traditional application of mapping, geological surveys, meteorology, and natural resources application, and its exploration. It is now being more enhanced using the gallium nitride so that it can give a better response and a better resolution. Gallium nitride characteristic gives broader application for LiDAR such as real-time motion detection for video games for kids, computers with response for hand gesture, fully autonomous vehicle. An example for fully autonomous vehicle is the Google self-driving car, which is also having a LiDAR on the top, which detects the area around it and the maps and makes a figure and gives directions and coverage to the car. So it is this technology coming because of gallium nitride and can enhance more because of that. So this is a very important aspect of gallium nitride. Now we'll be looking at medical power aspect of gallium nitride. As you know, there are many heart patients which have problem in the pumping. So there is a device called pacemaker, which has a battery installed in it, which is used to pump the heart properly. So the battery could expire in few years, but it's very hard to change the battery as it needs surgery and remove the device and put the new battery. So if we are having wireless charging through using this gallium nitride, so the battery charging will be easy. There would not be any surgery, and even the imaging technology is also improving at an extraordinary pace. The resolution of the MRI scans, which is used for the human body detection and the things going within the body, so those can be improved. The resolution can be improved using gallium nitride. So this gallium nitride in medicines, it also has very important aspect of it. So gallium nitride's coming up in many of the application except the day-to-day life. It is also coming into medicine. Using this compound will give many more benefits like thinner televisions by improving switching frequency 100 kHz to 1 MHz, smaller power adapters which increase range by reducing heat losses. It will also give us new high frequency architecture enabling the gallium nitride for data centers and datacom higher efficiency applications. Even the packing for reliable and thermal excellence, low susceptibility of cosmic rays, and the high density and efficiency battery charging in vehicle, also the ultra small efficient DC converters can be used by this gallium nitride technology. Now coming to a conclusion, I think gallium nitride is coming up the next semiconductor in power electronics as it has reduced heatsink requirements, it has increased the switching speed and improved the transient characteristics. It has given such application like LiDAR, RFDC and many more in the medical and reduced the weight of many of the devices. It comes as like it has a very nice improving efficiency of any of the device using this gallium nitride. So I think it is coming up a figure of merit in the field. So I hope this is the coming generation's new semiconductor for the power electronics. So this is the end of my slides. Thank you for watching.